The V05 family office owns non-dividend paying shares of Valuation that are currently priced at $2.95 per share. VFO's CIO is considering an offer to sell shares at a forward price of 300.84 in 6 months based on the risk-free rate of 4%. You've been asked to advise on the purchase of a put option or the sale of a call option with an exercise price equal to the forward price. Your exercise price is 300.84. It's telling you here your exercise price will equal the forward price. So as far as the put, let's just think about this for a minute. If this is the exercise price and this is the current price, the put is in the money. As far as the call, if this is the exercise price and that's the stock price, the call is out of the money. Equal to the forward price as alternatives to the forward sale. There is our setup. There is the basis on which we must answer our questions. VFO is considering the purchase of the put option to hedge against a decline in Valuation's share price. Which of the following statements best characterizes the trade-off between the put and the forward based on no arbitrage pricing? So we can either sell a forward with a price of 300.84 or we can buy a put with a strike price of 300.84. Entering the forward costs us nothing. The put is going to cost us something. Actually, I shouldn't put dollar signs because we're not in North America here. INR. Okay, let's see what we have. The gain on the forward sale. How do we gain on the forward sale? Since we're selling this forward, the gain would be if the price dropped, then the forward contract would gain. The gain on the forward sale will equal the purchased put option's profit at maturity, provided the put option ends up in the money at maturity. Well, no. The forward price is whatever the price is minus whatever the stock price is. If we're talking about having a profit on the forward, the price would have to drop. This is just a forward contract, by the way. You may get confused saying, but don't we own the underlying and have the forward and hence we're hedged? This is only talking about the forward contract. The gain on the forward contract would be the price minus the stock price. Whereas the put, you would have the value of the option at expiration minus the cost of the put. Notice that this is lower than the forward by the price of the put. This is saying they will equal. They will never equal because you will always have the price of the put in the profit from the put that you don't have in the forward. Get rid of A. The loss on the forward sale. How do we get a loss on a forward? If we sold forward, we get a loss if the price goes up. The loss on the forward sale will exceed the loss on the purchased put at maturity if Valuation's share price exceeds the forward price by more than the initial put premium paid. Remember, this would be our loss. Right? This will be less than 0, 300.84 minus ST. Let's say it ends at 304. Well, there's $1.16. That's $3.16. $3.16 per share loss from the forward contract. And if it ends at 304, the put is out of the money. What do you lose on the put? Just the premium. That's it. So the loss on the forward sale will exceed the loss on the purchase put at maturity if Valuation's share price exceeds the forward price by more than the initial put premium paid. That's true. There we go. C, we do not have enough information to answer this question. Well, we did answer this question, so we know we have enough information. In evaluating the purchased put strategy with the strike price equal to the forward price, the CIO has asked you to consider selling the put in 3 months' time if its price appreciates over that period. When we say its price, the price of the put, which of the following best characterizes the no arbitrage put price at that time? We have an option here, so we can't really talk about the no arbitrage put price, but we can talk about the no arbitrage put price range. We'll have some lower bound and some upper bound, and this is what they are. As VFO will exercise only if the spot price is below the exercise price, the lower bound of the put, there's our lower bound, is the greater of 0, true, and the present value of the spot price minus the exercise price. So close. It's the present value of the exercise price minus the spot price. Get rid of that one. As VFO will exercise only if the spot price is below the exercise price, the upper bound, here we are up here, of the put price equals the present value of the exercise price minus the spot price. The upper bound equals the strike price, We can get rid of that one. The put price can be no greater than the forward price. The forward price here is our strike price, right? So we set the strike price equal to the forward price, so it's just playing with you here. It's no greater than the strike price, but the strike price is the forward price. So no greater than the forward price and no less than the greater of 0, true. And the present value of the exercise price, yes, minus the spot price, yes, checked all the boxes. It's C. VFO is considering a sold call strategy. If you're confused about what's a sold call, just think of short call. We're just going to sell a call. Considering a short call strategy to generate income from the sale of the call. In your scenario analysis of the sold call option alternatives, VFO has asked you to value the call option in 3 months' time if Valuation's spot price is $3.25 per share. Given an estimated call price of $46.41 at that time, which of the following correctly reflects the relationship between the call's exercise value and its time value? Well, we're going to have to do some calculating here. We're saying in 3 months' time the price will be $3.25, so it's $2.95 now. ST will be $3.25, and our exercise price is $300.84. So to figure out what the exercise value is, we will use this term right here. We know that the call itself is equal to the exercise value plus time value. We're just not given what time value is, but we have exercise value. We're told 46.41, so we have that here. We have the 325 ST. We have the X, which is the strike price, and we were told the risk-free rate was 4%. We were told initially it was a 6-month contract, and we're told that we are now 3 months in, so we must have 3 months left. And then we just solve for time value. We'll get 1931. The call's exercise value is 24.16. No, it's not. It's 27.10. The call's exercise value is 27.10. Yes, it is. And its time value is 1931. It would have to be 1931. Yes, it is. So obviously it's B. Here the call's exercise value is 20.99. No, it's not. It's 27.10. In comparing the sold call and purchase put strategies at the forward price, VFO's CIO is concerned about how an immediate increase in the volatility of the underlying Valuation shares might affect option value. Which of the following statements about this volatility change and its effect on strategy is most accurate? Well, we know as volatility increases, both the call and the put value will increase. We are selling a call and we are buying a put. In the original strategy setup, it said that we are evaluating either buying the put or selling the call. Well, if we're selling the call, we'll get higher income. If we're buying the put, we're going to be facing a higher cost. A, an increase in the volatility of the underlying shares has the same effect on the call and put option values. That's true. So this change should not affect VFO's strategy decision, but it will affect the decision. You have a higher cost on the put, so we can get rid of that. Since changes in the volatility of the underlying shares have the opposite effect on put versus calls, get rid of that. It has the same effect. It'll increase the value on both. An increase in the volatility of the underlying shares will increase both the cost of the purchase put strategy, true, and the premium received on the sold call strategy, true. So this change will increase the attractiveness of the call strategy versus the put strategy. Very true. There we go, C. In comparing the Valuation purchased put and sold call strategies, which of the following statements is most correct about how the call and put values are affected by changes in factors other than volatility? And I've replicated an exhibit from the reading here, and I will explain this over here, because in the reading we did not explain how it could actually be minus for a put. Time to expiration increases call value, increases put value, but there is a condition under which it would actually reduce the put value. I'll explain that as soon as we're done this question. Changes in the time to expiration, here we are here. And the risk-free rate, where's the risk-free rate? Here we are here, have a similar directional effect on the put and the call. For the time to expiration, we can say yes, that's true, but for the risk-free rate, no, it is not. Have a similar directional effect on the put and the call, while changes in the exercise price tend to have the opposite effect. So no on risk-free rate. Changes in exercise price tend to have the opposite effect. There we go, right there. We can see that it's opposite. So one is wrong, one is right, the whole thing is wrong. Changes in the time to expiration tend to have a similar directional effect on the put and the call. Yeah, tend to have a similar directional effect, while changes in the exercise price and the risk-free rate tend to have opposite effects. Exercise price, opposite effects. Risk-free rate, opposite effects. There we go. Changes in the risk-free rate have a similar directional effect on the put and the call. Well, we know that's wrong. While changes in the exercise price and the time to expiration tend to have opposite effects. Well, exercise price has opposite effects. Time to expiration does not. We can get rid of that. Let me explain this negative sign. Typically, when we have more time, and we'll draw out the payoff of a put here. It looks like this. When we have more time to expiration, you tend to have, convexity that looks like this. However, if we have a strike price that's way, way, way up here, and the stock price is way down here, this is called deep in the money. Very deep in the money. The deeper in the money you go, the lower the time value component is of it. Now, if you have to wait, let's say it's 3 months to expiration, you're over here, you have to wait for time T. You could get this much money if you could exercise today. You could get X, but you can't. You got to wait 3 months. And you have a stock price that's way down here, but you know you're going to get this, but you got to wait 3 months. If you could get it today, X would earn interest over that period of time. When the interest you could earn by getting the strike price now is greater than the time value component, it actually drags down the price of the put because now it's a cost to hold the put because you could make more if you had the money now.